2.3, Angles and the Angle Addition Postulate, and Unit 2, Segment and Angle Relationships. We begin simply by answering the question, what is an angle?
Okay, let's get started. First of all, what is an angle? Well, an angle is simply, in a very loose sense, an amount of turning. For example, if I were to turn one full turn, okay, I'll do it, here goes, one full turn, I've just turned through an angle of one full turn. I can actually turn through an angle of two full turns by doing a double spin. Okay, I'll do it, why not? One full turn followed by a second one makes for an angle of two full turns. Now, of course, you don't have to do a whole number of turns. You can do fractional turning as well. For example, I could just turn half a turn. Let me turn through an angle of half a turn, and then you get to see my back. All right, do another angle of half a turn, I'm back to where you are. But I'm actually getting quite dizzy right now, so rather than turn my body, let's actually turn an object. In fact, in this course, let's push pencils around, or for me, since I've got a screen here, I'll push markers around. Let's apply some turning to different markers. For example, I was just holding that marker that direction right there, so let me mark that direction. There it is. Let me apply, say, quarter of a turn to that marker. Let me go, say, that direction. I'll go either way, but I'll go this direction. A quarter of a turn, I think, is about there. So I would say that is about a quarter of a turn. If I did a good picture, you could actually start this side and go the other direction and still say that's a quarter of a turn. So whether you go clockwise or counterclockwise, it's all fine, same amount of turning. Though some mathematicians will say, let's consider one direction positive turning and the other direction negative turning. So we can do that later on, but for now, it doesn't matter which way we go, that's a quarter of a turn, that's also a quarter of a turn. But you can see on the board, we've got all sorts of turns here. It looks like this one here is about 1/6 of a turn, would you guess? 1/6 of a turn. What's this one? Oh, this one is our two full turns. You can see it went like probably going off the screen, but one full turn followed by a second full turn. Oh, not very exciting. It's kind of a strange picture because after two full turns, the marker's back to where it started. In fact, let me do that. Let me draw it here. If I start the marker here, there is a picture of 0 full turns. Yeah? Start doesn't do anything, just there it is. If I apply one full turn to it, then I get the same picture. That's it. If I apply two full turns to it, like up here, I get the same picture. But if I look at this picture right here, it's pretty simple, and therefore it's confusing because this actually represents no turning, one full turn, two full turns, three full turns. Very strange picture. In fact, pictures can be a little delicate. For example, if I did half a turn like I did earlier, so I start the marker this direction, say, and I apply half a turn to it, it's like me facing the other direction. You saw my back when I did half a turn. The marker's now facing this direction. I get a very flat picture like this, and that's half a turn. All right, grand. And this is a picture of, I don't know, one full turn, two full turns. Maybe I should mark it like that or something. I want one full turn. All right, brilliant. So here's some angles. Here's a big angle. Looks like it's almost 3/4 of a turn. This one looks like it's about 1/6 of a turn again. Maybe it's 1/5 of a turn. Beautiful. All right, but actually, look at these pictures. Because I'm talking about turning and an amount of turning. That's a very intuitive idea in my head. It makes good sense to me. I feel what a turn is. But I really felt what a turn was. But if you look at a geometry book, they might just say an angle is something much simpler than that. They'll just say, look at the pictures on the board right now. And they say, we shall define in this course simply to be two lines or two rays or two line segments emanating from a common vertex, common point. So they call a point like this a vertex. And they say, look at that picture in pink. That is an angle. Okay. No mention of turning. That's an angle. Okay. Clearly, you want to think turning when you see a picture of two lines coming from a common point. So this is meant to represent turning in our brains for our intuition, but the actual definition in books is just draw two lines coming from a common point. That's an angle. But there is a point of confusion here. When I look at this picture here, I actually see two different angles. Actually, I can see more than two different angles could be part of that picture. Do you see it too? When I see a picture like that, just cold, no writing, no context, I say, okay, does the author want me to think this amount of turning, the small angle? Or does the author want me to think of the big angle? Do you see there's a big angle there? I could turn this way. So there's two angles this picture could represent, two amounts of turning. Or if I get a little bit crazy, maybe it means 1 full turn plus a little bit more, that angle. Or maybe it means 2 full turns plus a little bit more to get that angle. So actually, this picture represents an infinitude of different amounts of turning. All right, so here's what happens. If an author says nothing more, says, here's my angle, the social convention is to assume the author is referring to the smallest possible angle, smallest possible amount of turning that picture could represent. So it'll be the small amount of turning there. If he or she meant, no, I meant the big angle, the big outer one here, then they would have to say that too. Write it down in the text, say it to you out loud, do something to indicate they meant the outer one. Kind of like I did here. All right, so that's it. An angle is just going to be represented by 2 lines, like I've been doing, coming from a common point, and voila, we will assume we're always doing the smaller angle unless told otherwise.
Okay, so we have got some concept of what an angle is now. So let's look at some vocabulary. An angle consists of 2 different rays, like ray AB and ray AC, as you see in the picture here, with the same endpoint, which would be A. The rays would be called the sides of the angle, and the endpoint, A, would be called the vertex of the angle. The angle with sides AB and AC would be named BAC or CAB, or even just angle A if it's the only angle with the vertex A in the diagram. So let's look at some ways to name the angle that you see here. We're going to name 3. And just as the guy said, we'll only be looking at the smaller angles. It would be unconventional of us to look at this big outside angle unless we were otherwise told. First angle I see, WXY. Or I could name that YXW, so long as I'm putting the vertex in the middle, as you can see here. Next angle I see would be YXZ, or I could name it ZXY. Again, so long as I put the vertex in the middle of the name. And one more, the outside angle, WXZ, completely ignoring this inside ray. We should not name any of these angles angle X because there's too many angles that share that common vertex.
Hey everyone! What can you observe from these clocks other than the time they show? One of the most important shapes in geometry. Many concepts in geometry are based on this, so did you figure it out? Here we are talking about angles. Every time the hand of the clock moves, it forms a different angle, right? Angles is basically a combination of 2 rays with a common endpoint called as a vertex. And the word angle comes from a Latin word angulus, which means a corner. So a few basic type of angles are acute angle, obtuse angle, and right angle. Acute angle, where acute means sharp, and these angles measures anything between 0 degrees and 90 degrees. Well, an angle which have maybe a measure of 1 degree or maybe 89.99 degrees. But both will be acute angles only. And surely we must have observed them in various of such places. The next type of angle is called as a right angle because the measure of the angle is 90 degrees. And based on this angle, you will learn a very important concept of trigonometry. Now the last one is obtuse angle, where obtuse means blunt. So can you guess what will be the range or what will be the measure of these angles will be? Right, since the acute was sharp and it was less than 90, so here obtuse means blunt, so it will be more than 90 and it will be less than 180 degrees. angles cover only the 3 type of clocks that we have shown. But then what about the 4th clock? Right? We missed that one. The 4th clock also shows an angle called as a straight line angle. And this angle measures 180 degrees. Well, what do you think this angle can be called as? So if you guys said that it's an acute angle, then you're correct. But then we do have one more type of angle in here. Can you think what it will be? The measure of these angles is more than 180 degrees and less than 360 degrees. And such angles are called as reflex angles. Have you ever thought a circle as an angle? Well, it's strange, right? But then this is called as a full angle, and the measure of this angle is exactly 360 degrees. If we see the clocks, there were only 2 hands. So let's take a watch with the 3rd hand also. Now here we can see 2 angles, but they have a common arm, right? And these type of angles are called as adjacent angles. Now just because the 2 angles are side by side or adjacent to each other, these are called as adjacent angles. Now we know when an angle is cut by another ray, we have adjacent angles, right? Now, when the addition of these adjacent angles is 90 degrees, these angles are called as complementary angles. And when a straight line angle is cut by another ray, these angles are called as supplementary angles. Well, supplementary angles are also called as linear pair of angles. Linear because they lie on a straight line, and there are 2 angles, hence a pair. Can you believe that till now we have learned about 9 different types of angles? Let's make a round figure by learning one more type of angle. Well, there is one more type of angle hidden in this clock. Can you figure it out? These angles are called as vertically opposite angles. And one of the interesting facts is that the vertically opposite angles are always equal. Well, there are various different types of angles. And if you want to learn about them, you can watch our video on lines and angles. Till then, observe and apply the math around you.
Okay, if you did not pause the video and take notes on the different kinds of angles, you can see here that I have shown you how to classify angles by acute, right, obtuse, and straight, assuming that you remember what complementary and supplementary mean. If not, go back to the previous slide and take notes on the video. Note one more thing. When reading a diagram in geometry, if you see a little red square, or really the square can be any color, that little square inside an angle means that angle is a right angle or 90 degrees.
You can use a protractor to measure angles. This full circle protractor is 360 degrees. A standard protractor is half a circle. There are 2 sets of numbers. The red counts one direction and the blue counts the other. So it is 180 degrees. There are 90 degrees in a square corner and 45 degrees in half a square corner. Let's take a look at this angle. We can use a protractor to measure this angle. First, put the vertex on the center. We're trying to find out how many degrees fall between the 2 arms of the angle, which we do by finding the difference. We can find the correct measurement of the angle as long as we use the numbers of the same color. One arm of the angle points at the 0 on the right, which is blue, so we can look at the blue numbers starting at 0. The other arm of the angle points at the blue 40. To find how many degrees are between the arms, let's find the difference. 40 minus 0 is equal to 40. This angle is 40 degrees. 40 degrees makes sense since this angle is acute, or less than 90 degrees. The other number this arm is pointing to is 140. 140 degrees would not make sense since this angle is acute. Let's look at another angle. One arm of the angle points at the 0 on the left, so we can look at the red numbers starting at 0. The other arm of the angle points at 120. To find how many degrees are between the arms, let's find the difference. 120 minus 0 is equal to 120. This angle is 120 degrees. 120 degrees makes sense since this angle is obtuse, or greater than 90 degrees. The other number this arm is pointing to is 60 degrees. 60 degrees would not make sense since this angle is obtuse. Sometimes neither arm points to 0. For example, look at this angle. Both numbers we look at need to be the same color. Let's look at the blue set. One arrow points to 50 degrees and the other points at 130. Because neither arm of the angle points to 0, we can do 130 minus 50, which is equal to 80. It is 80 degrees from one end of the angle to the other. We can use the red numbers to see if we get the same measurement. One arm points to 130 and the other points to 50. We can subtract to find the difference. 130 minus 50 is equal to 80. It is still 80 degrees from one end of the angle to the other. We can find the correct measurement of the angle as long as we use the numbers of the same color. In this lesson, you learned to measure angles using a protractor.
Okay, so what we have now is called the protractor postulate, which is what she was just using to measure an angle. It says that on any given protractor, that you can find the measure of angle AOB by looking at the difference, which means subtraction, between the real numbers for ray AO and ray OB. Notice that we would say the measure of angle WXZ is 32 degrees, or we could use symbols or notation to say M as in measure of angle WXZ is equal to, with the equal sign, 32 degrees. So let's measure some angles. KHJ. So if I look over here at KHJ, I see that HJ points at the 0 inside number. So I'm going to stick with my inside numbers and I'm going to go up the protractor until I find where K meets the protractor. So HK meets the protractor between 50 and 60. Let's assume 55. So 55 minus 0 is 55. And 55 is less than 90, which makes it an acute angle. Next, let's look at GHK. GHK. HG points at 0 on the outside number of the protractor. So I'm going to stick with the outside numbers for this one. And I'm going to go around the protractor until I find where HK runs into the outside numbers. And I see it's halfway between 120 and 130 as I read it this direction. And so I would have 125 minus 0, which is 125. 125 is greater than 90, so this is an obtuse angle. Next, let's look at GHJ. GHJ goes from 0 to 180, or 0 to 180, depending on whether you're looking at the inside or the outside numbers. But regardless, it's just a straight angle, and we call a straight angle 180 degrees. Last, let's look at GHL. GHL. GHL goes from 0 on the outside to 90. Or we could look at the inside numbers and say it goes from 180 to 90. Well, 180 minus 90 is 0, or 90 No, I'm sorry. 180 minus 90 is 90, or 90 minus 0 is 90. Notice that 90 is true for the outside and the inside numbers, because whether I'm looking at the angle from the left or the right, it's right in the middle. And we call this a right angle. Next, we're going to look at the angle addition postulate. The angle addition postulate says, pretty similarly to the segment addition postulate, where I can say part plus part equals whole. So in words, this angle says if P is in the interior of angle RST, okay, so angle RST is this outside angle, and P is in the interior, right? And interior simply means inside the angle. Then the measure of RST is equal to the measure of RSP plus PST. And I can actually set it up as an equation as you see here. Let me say it one more way. Let's say I begin with an angle, and the angle is 60 degrees as you see here. And I create an adjacent angle. Remember, that's one that shares a common side. And that angle is 80 degrees. Angle addition postulate says that I can find the measure of the outside angle, or this big angle that those two adjacent angles create, simply by adding 60 plus 80 and getting 140 degrees. Pretty simple. Let's look at an example. Given that we know the measure of LKN is 145 degrees, find the measure of LKM and MKN. In order to find the measure of these two angles, I'm going to need to figure out what's the value of x. And so what I see here are two adjacent angles where I know I'm given the big angle LKN. So first, let's just write the angle addition postulate, which says that LKN is equal to the measure of LKM plus MKN. So this whole big angle right here is equal to part plus part. Then I'm just going to substitute. So for LKM, I'm going to put in 2x plus 10. And for MKN, I'm going to put in 4x minus 3. And now I'm just going to take this equation and solve it. So the first thing I'll do is I will combine like terms. 2x and 4x give me 6x. 10 minus 3, or 10 plus a negative 3 is 7. Then I'll subtract 7 from both sides of the equation. And 145 minus 7 is 138. And then divide by 6, and you get 23. Once you know that x is equal to 23, then finding the measure of these two angles, LKM and MKN, is just a matter of substituting. So we know that LKM is 2x plus 10. And we now know what x is. So we can find the measure by just multiplying 2 times 23 and then adding 10 to it to get 56. And I'm going to find MKN similarly. MKN is 4x minus 3. Substituting in x, we get 4 times 23 minus 3, and we get 89. Using our calculators, if we were to combine 89 and 56, we would get 145. So that means the measure of LKM is 56, and the measure of MKN is 89. Not every time when you're given a diagram are they going to explicitly tell you what the outside measure is. You're going to have to figure that part out. So it says, given EFG is a right angle, meaning is equal to 90 degrees. Find the measure of EFH and HFG. So again, the first thing that we need to do is we need to set up an equation using angle addition postulate to solve for x. Let's begin. The first part I see here is 2x plus 2. If I combine with that x plus 1, I have created all the space that is equal to the 90-degree angle. Combining like terms, I get 2x plus x is 3x. 2 plus 1 is 3. And that's going to be equal to 90. And then quickly solving, subtracting 3 from each side to get 87, dividing by 3 to get x is 29. Remember, x can be positive or negative because it is simply a variable in this problem, not an actual angle measure. It's not here, but it could be. Now I do the easy part where I solve for EFH, right? We know EFH is 2x plus 2. And we know x is 29. So we're just going to have 2 times 29 plus 2, which is going to be 60. Similarly, we'll solve for, and I said EFH again, but this should be HFG. I'm sorry, typo. Substituting in your 29, giving you 30. And then check your work by making sure that when you combine 60 and 30, you get 90, which is a right angle. There's a quiz for practice and a quiz following that. Good luck.